always mean finding patterns and crafting beautiful and meaningful explanations which helps to arrange one's ideas. The essence of mathematics is not to make simple things complicated, but to make complicated things simple. Engineering mathematics is a subject which breaks all the complexities and produces wonderful products that are useful for the society. And that's the reason we have engineering mathematics in all the branches of engineering. Maths, together with science and creative mind, can make wonders. Good company and good welcome can make good people. I now invite Dr. V. Vijayalakshmi Ma'am, Assistant Professor, Department of Maths, to render the welcome address.
Good evening to one and all present here. I am fortunate enough to get the opportunity to welcome everyone present here. Firstly, I would like to welcome our beloved Principal, Dr. Srinivasa Ramanujan sir, and Vice Principal, Dr. Murugan sir, to this great evening. Now, I extend my warm welcome to the distinguished Chief Guest, Dr. R. Pugarasu sir, PhD, Head of Maths Section, University of Technology and Applied Sciences, IWRAEM Institute, Sultanate of Oman. We welcome you, sir. It is a jubilant opportunity to welcome our Head of the Department, Dr. S. Chitra, and the Department of Physics, Dr. H. Krishnan sir, and all the faculty members who works hard to the betterment of the young India. Welcome, teachers. Next, I would like to welcome our loving audience who has joined us on this webinar. I welcome you all. Last but not the least, I extend my hearty welcome to all the students who has joined in this event. Welcome, students. Once again, I welcome everyone who are the part and parcel of this event. Thank you.
Thank you, ma'am, for your words of welcome. If you can dream, you can do it. It's time for introducing the chief guest of the day, Dr. R. Pugarasu sir, PhD, Head of Maths Section, University of Technology and Applied Science, IWRAEM, Sultanate of Oman. May I now invite Dr. T. Isaiwani ma'am, Assistant Professor, Department of Maths, to give the introduction to the chief guest.
Good evening, all. Welcome all for the webinar. It is my distinct privilege and honor to introduce the guest speaker, Dr. Pugarasu, for the international webinar on recent advancements in engineering mathematics. Dr. Pugarasu completed his BSc Mathematics degree in 1996 and MSc Mathematics in 1998, and he has completed his MPhil in 2000. He completed his doctorate in 2011.
Hello, can you hear me?
Yes, sir.
Yes, sir. Yes, sir, please, sir.
Yes, sir. Hello, can you hear me? Good evening to everyone.
Yes, sir. Yes, sir. Yes, sir. It is audible, sir. Please, sir.
Yes, sir.
It's audible.
Hello, Vijayalakshmi ma'am, can you hear me?
Yes, sir. Yes, sir. Yes, sir. VP sir, welcome, sir, to our webinar.
Professor, it is audible only, sir. It's very much audible. Very much audible.
Ah, is it okay, ma'am?
Yeah, it is. It is absolutely
Okay.
fine, sir.
Okay. Sorry.
No problem, sir. Madam is introducing about you, sir.
Ah, okay. It's already introduction over or going to introduce?
No, it is.
No, sir, just now started, sir.
Okay, ma'am.
Yes, ma'am, you proceed. Yes, ma'am.
Yeah, yes, ma'am. It's my distinct privilege and honor to introduce the guest speaker, Dr. Pugarasu, for the international webinar on recent advancements in engineering mathematics. Dr. Pugarasu completed his BSc degree in 1996 and MSc Mathematics in 1998 and MPhil in 2000. He has completed his doctorate in 2011. Dr. Pugalarasu has 22 years of teaching experience. He started his teaching journey as a lecturer from Loyola College, and then he moved to Jaya Engineering College as a senior lecturer and worked there for 6 years. Later, he joined as an associate professor at RMD Engineering College, and he worked there for 7 years. Currently, he is the head of Maths Section, University of Science and Technology, IWRAEM, Sultanate of Oman. Also, he has 16 years of research experience. He published 18 research articles in various national and international journals. Also, currently, he is guiding 2 research scholars. They are pursuing their doctorate under his guidance now. We are very much excited to listen to your lecture, sir. Sir, the session is yours. Over to you, sir. Sir, the session is yours, sir. Over to you. You can proceed, sir.
Good evening to everyone. Thank you so much, ma'am, for the brief introduction about me. I'm very happy to present in this today's international conference. First of all, before going to start my lecture, I would like to thank our organizing committee, Dr. Chitra, ma'am, HOD, SRM Valliammai Engineering College, and then the coordinators, Dr. Isayarasi and Vijayalakshmi ma'am, for inviting me for this today's lecture. Let me start our lecture. Now, kindly check whether you're getting my screen. Are you getting my screen, ma'am? Please check it. I'm
not yet, sir. Not yet, sir.
Someone used to spotlight, ma'am. Ms. Sudhadharan, sir, maybe.
Kindly check now, ma'am. Is it okay?
Yes, sir. Now proceed, sir. No problem. No proceed.
Yes, sir. Yes, sir.
Okay.
Yes, sir.
Thank you. Thank you. So good evening, and once again, good evening to everyone. I'm Pugalarasu, head of mathematics section at the University of Technology and Applied Sciences, IWRAEM, Sultanate of Oman. With you today for the topic recent advancement in engineering mathematics. So I'm very happy to present this topic. Nowadays, all the teachers and fellow that is lecturers, we are teaching for the engineering students. But many times the engineering student, they're going to ask the question, what is the importance of mathematics? Where I'm going to apply? Okay, so after receiving this topic, really, I was happy about to share this topic with my friends and then students. I hope some students also join in this international webinar. Definitely, they will get something from my lecture. Okay, so we'll start. So today in our talk, there is an introduction about engineering mathematics, then significance of engineering mathematics, mathematical tools, mathematical models, and finally, I want to conclude with recent developments in learning outcomes. Let me proceed with the introduction. As everyone know that, and most probably that research scholars and those who are doing projects, they know that in recent era, mathematics has experienced amazing growth in engineering sciences. Mathematical concepts provide common foundation to all engineering discipline or specialization Mathematical tools are very useful in innovative research and problem solving. And then the mathematical tools are very essential, especially in engineering modeling and programming. Everyone, we know that in engineering mathematics, there are several branches, okay, not limited to electrical engineering, electronic and communication engineering, civil engineering, computer science engineering and information technology, mechanical engineering, biotechnology, sorry. Ma'am, whether I'm audible, because I'm getting some disturbance. Whether I'm audible?
Yes, sir, you are audible, sir. Audible only, sir.
Fine, fine. And then biotechnology, biomedical engineering, etc. So in all engineering specializations, we are teaching mathematics to all our students. But even though in each branch, we have different study skills. In each study set, different mathematical skills are taught in various universities and colleges. Let me introduce, otherwise discuss with you some significance of engineering mathematics in our engineering discipline or engineering specialization. First one, electrical engineering. In electrical engineering, the first one, differential equation is essential for solving circuit equations and analyzing the what circuits. Especially it's very common. Students also experience the differential equations are very important in analyzing the RLC series circuit, otherwise current flow in the circuits. Next one, calculus and triple integrals, as well as integration over a closed surface is very useful in electromagnetic theory. Laplace transform and Fourier transform are very useful in circuit theory and signal processing. Mathematical complex numbers algebra find maximum use in solutions of sinusoidal excited circuit equations and power systems flow problems, and so on. So it is very difficult for me to figure out all the applications in electrical engineering and other engineering disciplines. Just I'm figuring out, otherwise I'm going to give you only few few areas of the engineering mathematics as an application mode. Electronic engineering. In electronic engineering, numerical method is very useful in solving engineering system which are non-linear. And then differential equation, yes, partial differential equation, integral calculus, vectors, matrices, statistics, probability and statistics help in performing best simplified calculations in problem solving and logical thinking. Next one, civil engineering. In civil engineering, mathematical equations are powerful tool in measuring the strength of the materials. Mathematical trigonometry is useful for surveying, that means surveying the what structure, land elevation, and various angle measurement of the structure. Probability and statistics are very useful and powerful tool in what planning and budgeting the what civil engineering projects. In mechanical engineering, calculus is very useful in figuring out the velocity and the acceleration of the vibrating object. In mechanical engineering, many machines are vibrating in nature, right? So there we can figure out, otherwise we can find the what velocity and acceleration of the what vibrating object. Then differential equation is useful to find out the exact equation for the displacement of nodes in vibration. Of course, Laplace transform, very powerful in engineering thermodynamics and heat transfer. In computer science engineering, mathematical models are essential to handle database queries of complex algorithms. Calculus, probability, and statistics are powerful in machine learning and artificial intelligence. Discrete mathematics provides basic foundation for programming and computer science, networking, and database. Next, we move to mathematical tools. Mathematical tools are very helpful in rapid growth of technology and sciences, such as biotechnology and biomedical engineering, communication systems, financial engineering, green manufacturing, manufacturing engineering, nanotechnology, solar and wind energy, smart city projects, etc.
Sir, excuse me, sir.
Yes, ma'am.
Sir, slide is not moving, I think so, sir.
No. It's okay now. Check it. Check it, ma'am.
No, sir.
Showing?
It is, now it is moving, sir. Thank you. Okay.
Now
Sir.
only? What about so far?
Yes, sir. Now it is moving. Okay, sir.
What about before, ma'am?
No, sir. It was in the first screen itself, sir.
Oh, sorry. Actually, I'm sharing. I'm sharing the screen.
Okay, sir. No problem. No problem.
Okay. Otherwise, I will keep it the same mode. Okay. So this and all we discussed now. Okay. So now we are moving to mathematical tools. So the mathematical tools, it is what very important in all engineering disciplines, or these are very important in recent science and development, especially in research and what project works. So we'll discuss a few application as a mathematical tools. We will see differential equation in mathematical tools. See that we have many applications. Just I'm going to discuss with you as an example, few examples with you. Deflection of beams. Okay, so if the beam is going to be deflected based on what a mass or force on the acts on the what beam, so we are going to consider that uniform cross section along its length as uniform. Then we can find what the elasticity of the beam by using what? By modeling differential equation. As an example, we'll see that beam one end is fixed, another end is free. In that free then in the next end, the end B going to what? Force, otherwise a mass going to act on it. So the beam going to be what? Displaced. So then elasticity, based on elasticity theory, so the governing equation is W of x equal to d square m by dx square. So we can find here the what? The elasticity of the beam by using what? A differential equation. So here we are going to take what? Boundary conditions and applying the derivatives y of 0, y dash of 0, and y double dash of 0, y triple dash 0 are equal to 0, because shear force in the other end is 0. So there is no force in the what? The free end. If you're going to give, there is a shear force. You know, shear force is what? Is a force to what? Dislocate the beam with respect to what may weight, otherwise the force. Okay, so here we can calculate the what? Displacement by using what? A differential equation model. Okay, so this and all we know that. Next one I want to discuss with you, Laplace transform in mathematical tools. So Laplace transformation is what? A powerful in our engineering. So again, I'm going to take what I want to discuss with you, the same beam using Laplace transform, deflection of the beam by using Laplace transform. Here, the beam is fixed in two ends. Both the ends are fixed. So the external force going to be, otherwise a mass going to be act on the what? Either center, otherwise the remaining points of the beam. Then we can find the what? The displacement, otherwise the what? The bend of the beam by using what? By governing the what? Differential equation by applying initial and boundary conditions. Okay, so here we can take Laplace transform, and then we can apply inverse Laplace transform to find the what? Displacement, otherwise bend of the beam. Next, I want to discuss with you mathematical operations in mathematical tools. See that, you know, array and matrix operations. So, array operation, it is what is array product operator. It is if you have A and B are two matrices, then array operator, otherwise array product is nothing but A dot star B. Then matrix product is nothing but A star B. This and all we know that. So how these operations are very useful in our engineering. Okay, so here, okay, the additive. So here we can check the linearity and non-linearity of H. Okay, if you're going to satisfy the above condition, then we can say that H is the linear operator. If it is not satisfied, then we can say that it is non-linear, otherwise non-linear operator. Okay, so here the important thing is, so we have 4 major arithmetic operations, plus, minus, multiplication and division. So I'm going to discuss with you array operations in the images. Okay, so see that I'm going to take what noiseless image as f of x comma y, noise image as n of x comma y, and corrected image as g of x comma y. Then we can write our corrected image is equal to f of x comma y, that is our noiseless image, plus a noise, that is n of x comma y. We can reduce the noise by adding the what noise images. If you're going to add the noise images, we can reduce the what noise in the system. So the G bar, the average, is equal to sum. Okay, you have to take the sum of the what images. Then we can find mean and the standard deviation. Okay, so that is the procedure. We know that we can find mean and standard deviation. So how these operations are very helpful in astronomy. Listen here. In astronomy, imaging under very low light levels. So the image is going to take very low light level. Then the image definitely won't be not clear. Then if you're going to take the image averaging, we will what reduce the what noise in the what image. See here kindly check that whether you're getting my. Are you getting my screen? I convert into yes, sharing mode slide is invisible, right? Yes, okay. Here you can see it. Yes, sir. Thank you so much. Here we can see 6 images, A, B, C, D, E, F. Here A is the what image with what additive Gaussian noise. Okay, so now see that next to images, we are going to take more images. Okay, we are going to take what? We are going to add more images and take averages. See the second image, it is from 5, average of 5 images, then 10, 20, 50, and see the last one, if you're going to take what more images and take average, so that we'll get what a clear image. Okay, so this is the what by what operation. So next one I want to discuss with you. First one is addition. Next one, subtraction here. So here we are going to take what mask, that is h of x comma y, that is X-ray image of your region of your patient's body. Then live image is called as f of x comma y. Then enhanced image, that is g of x comma y. The enhanced means is a difference between f of x comma y and h of x comma y. Then we can process. I'll show you the example. See here we have 4 images. The first one is mask image, second one is what a live image, and B, that is C, is nothing but difference between A and B. If you're going to take for first one difference, you cannot get it anything. Okay, if you go for more differences, more number of time, if you're going to take the difference, that means enhance image, it's give you what a clear picture what you are expecting. Okay, so this is done by using what operation, that is our arithmetic operation. I can show you another example here. Okay, so the figure A, that is picture A, otherwise image A, is a shaded sim image of a tungsten filament and the support. It is what is the image of the tungsten. So then the B is nothing but shading pattern. Okay, the C is nothing but product of A and reciprocal of D. So here we are going to apply the remaining two operators, that is a product and what reciprocal, to get the what the clear image. So in the C, after applying our arithmetic operations, we'll get the what a clear image. So these are the what very important, the powerful applications, otherwise tools using in our image processing. Next one, mathematical tools, that is a linear transform. So application of that is involvement of linear transform in mathematical tools. Everyone, we know that Laplace transform, Fourier transform, and other transforms are very powerful in our engineering. So two-dimensional linear transform. So we know that there is a transform, and there will be a what inverse transform to convert the what image back. Okay, so this and all we know that. So here I want to show you so that the transformation system, so the transformation process. So first one, f of x comma y is a what a spatial domain. Then we are going to apply the transform operator and then inverse transform, and finally we get to what a spatial domain, that is over a g of x comma y. See here the one important thing is the DCD transform. So what is DCD transform? It is a dual clutch transform. It is we can say it as multi-speed vehicle transform system. So in our car and in the multi-speed vehicles, we have more number of gears, right? So by using DCD transform, we can what separate the what odd and even gear sets. So we can separate it. So the same transformation is useful in the image processing. See, the first figure is the what image corrupted by sinusoidal inference. Then B is what magnitude of the same image by Fourier transform, and the C is what mask used to claimate the energy burst. Then see the last one, result of computing the what inverse of the a modified Fourier transform. So if you're going to apply the inverse Fourier transform, we are going to get the what the clear image. Okay, so this linear transforms are powerful in our image processing. Okay, so the next one, probability in mathematical tools. So the probability is what playing important role. So you know the probability theory. So some of the probability equal to 1, then we can take a mean, average, intensity. Okay, so the mean, average we can take here. See the variance. So of the mean we can find the what variance and the nth movement of the what intensity variable is that. Okay, so this and all we know that these are the basic of concept of the probability. So how the probability useful in our image processing? See here, comparison of standard deviation values. See here, if the first image shows that there are a less number of the data, otherwise the what we are going to take minimum data, or otherwise minimum picture, and take the what standard deviation. If you're going to increase the what more, that is you're going to take more picture, okay, and increasing the what variance. If you're going to increase the what standard deviation, we are getting what a clear picture. So if the standard deviation is 14.3, see the clarity of the picture. If the standard deviation increased to 49.2, so we are getting what a clear image. So this is the what very important important of mathematics, that is probability as a what mathematical tool. So still we can explain many areas. So all our mathematical things club together, we are using as a mathematical tool. So these mathematical tools are very powerful in everywhere, not only the image processing. Just I put some examples in image processing. We can use this mathematical tool everywhere, but I'm going to discuss with you in a different angle that application of mathematics, otherwise mathematical tool. The first one, I'm going to discuss with you mathematical models, because here I want to conclude, at the end of our presentation, I want to conclude what a gap. Okay, the gap, one of the gap is what the mathematical models, the students, otherwise the researchers, they are not aware of the what mathematical models. Okay, fine. Here, mathematical model using in biomedical. So in our recent past, the situation are worst, right? So here there are what more mathematical models available to identify the transmission pattern of what COVID-19. Okay, so here you can see the pattern. You can see the pattern here. Just I want to Okay. I think it's visible, right? Is it visible, ma'am? Hello?
Yes, ma'am.
Yeah.
Yes, sir. Visible,
Yes,
sir.
sir.
Yes, sir, it
Yes,
is
sir.
visible.
Fine, fine. Because I'm changing the slide. I don't know what is the problem in the technology. Okay, no problem. So transmission pattern of COVID-19. Just here I'm discussing what a few mathematical models which are currently in trend. See here. So here, this is what a transmission pattern of COVID-19. So here we have yes. See that? This is yes. So yes is nothing but susceptible individuals that is expected to affect by the COVID-19. Next one, this E of T is exposed individual, and then IA of T is asymptotically infected individual, and then IS of T. This is IS of T. This is symptomatic infected individual. What is the difference between asymptotically infected individual and symptomatic affected individual? See that asymptotic infected individual means it is a person infected without symptom. And if it is symptomatic, we can say the person affected with the symptom. Then last one is what? R, it is what? Recovered individual. Okay, so this is the what? The pattern. Okay, so here we have the parameters. We have what? Parameters, mu, that is what? Mortality rate, and capital gamma is a capital gamma. So capital gamma is what? Natality rate, and the transfer rate is called as psi, and the beta is nothing but, see here you can see the beta contact rate between S and E, between what? Yes, and the susceptible and what? Exposed individual. And then what? Gamma. So there is a gamma rate transfer from E to Q. E to what? Q. E to what? Q. This is called what? Gamma. So there is a what? A parameter for everybody is connecting what? The transmission pattern. Okay. Here we know that this pattern is by using networking. You can draw the pattern. Here, what is our total population? So the total population we can say is N of T. So N of T, the total population is nothing but summation of L, that is yes, susceptible individual, and then exposed individual, quarantined individual, then IS plus we can say IA, asymptotic individual, then what? A result. That means what? Recovered. So this is nothing but the entire population. Okay, here what is the important of mathematical model here? See that what is the derivative that is ds by dt, rate of change of what? Susceptible individual with respect to time t. So see, this is we can write very easily. See that here what is ds by dt? Ds by dt nothing but, see, it is coming in, right? So this will be capital gamma plus, not plus, there will be what? Minus, because remaining going out, right? So the remaining are going out. So gamma, then minus of this one, and minus of beta se. Okay, so that is the first equation. So derivative, that is se, that is ds of t by dt. Okay, this is the first equation. Similarly, we can find the what? System of equations. Okay, the derivative for the remaining things by applying boundary conditions. We can solve the what? Finally, we can conclude that the transmission pattern of the what? COVID-19. Okay, this is the what? One of the what? Mathematical model, and one of the paper recently, not one of the paper, many paper they published what for the what? Pattern of COVID-19. We can say here virology. If you go and check in the net, we can see more mathematical models for virology and ecology. Okay, so the mathematical models are very powerful in what? In biomedical. Next one I want to discuss with you, data science. Sorry. Okay, see that data science. Are you getting my screen, participants? Are you
Yes,
getting my
sir.
screen? Okay, fine, fine. Because I changed the
Yes, sir.
slide
Yes,
here.
sir.
Okay, fine. What is how the mathematical models are very important in data science. Nowadays, social apps. We have everywhere social apps. If we have plenty of social applications, then definitely there will be an increasing flow of what data every day. So every day, what we are increasing flow of data. So social media platform, millions of users get connected on daily basis. Then if millions of people connected, definitely data constantly shared. So the social media platform and other websites in all our social media, many data are shared. Then what will be the problem? So what is the problem here? How this huge amount of data are going to be handled? So here the data science is come to in the picture. Okay, this is everybody that. Okay, fine. So in the data science, what is the backdrop? Okay, so nowadays, as the data sharing of the data, otherwise the huge number of data are sharing every day. So there is a backdrop. What is the backdrop? Number one, incomplete data. So there are plenty of incomplete data, lack of proper understanding of data. As we have many data, it is very difficult for a person, otherwise for a researcher, to understand the data. Next one, growth issues. Next one, confusion while tool selection. So much of tools available, which tool is suitable for my research. Lack of information professionals. So there is only we can say only few professionals are working in data science. So lack of information professionals. Securing the information, it is very difficult to secure the information and integrating data from variety of resources. So these are the backdrop in the data science. So there is a incomplete information system. The system is called incomplete information system. Here, errors in measurements are lack of discipline. So there is no discipline. Otherwise, there is a error in the measurement. Okay, so this is coming under that IIS. A big size and incompleteness of the data. So as the data is very big, so there is a incompleteness. Then rough set theoretic. So what is RST? It's a rough set theoretic algorithm. Okay, so what is this? This is converting incomplete data to complete data. Okay, that is using of the RST. Okay, so now I'm going to show you data science, how the model helpful to analyzing the data. So here the subset theory. So IIS, that is incomplete information system. So now we are going to divide the sets. So first one, RU I inverse. This is subset of IIS. Okay, so now there will be another subset. Then we have another subset. So in each and every subset, okay, we can get the output. So the blocks. So our UI inverse is called blocks, then objective, then class. Then for each class, we can get the outcome.
Sir,
Yes,
sorry to
ma'am.
disturb you. Your slide is not moving, sir.
Okay, still the same problem.
It is in just the mathematical model. Now it is moving, sir.
Okay. Okay, I'll repeat. Okay. So so far I discussed about data science. So in the data science, what are the problem we are facing? Actually, sorry for that. I don't know why the the slide is not sharing. Okay, fine, no problem. So here there are plenty of problems. How here we have the gap, and then how through mathematical modeling we can analyze the data. That means by using set theory. Okay, so we can split into subsets. Okay, so the each subset is called the block, objects, and class. So finally we can get output. Okay, so here see that IIS. So this is the universal set. The universal set divided into subsets. Each subset divided into minor sets. So there you can analyze and you can get the output. So this is the one of the model to I study about the data science. That means data. So the next one I want to discuss with you, mathematical model in smart city. Everywhere, we can say in each and every institution, there will be at least one smart city project takes place. Otherwise, it is a research, otherwise it's a funded project everywhere. Okay, it is a current trend, data science, smart city projects are what current in among the what researchers. Okay, in the smart city. Okay, if the city is well equipped, technology very good, technology is very good. Okay, fine. If there is no water management system, there is no power management system, and there is no proper waste management system, definitely everything will be what affected. That's why here I want to discuss with you few models, that is automatic flow management system. What is automatic flow management system? This is what current in what everywhere, um, in our regular life. We are getting water from our own resources. We have borewell. Okay, we can get the water from there. But in a smart city, there is no concept of borewell. So there will be a what automatic flow management system. So we will get the water. If you're going to use, if you're going to receive, or if you're going to use 1 gallon of water, so in the smart meter, so we have another project also, smart meter. So the meter, it will record at the end of the month, you have to pay for your usage of water. Okay, automatic water flow management system. What is here? Uh, Here, this is what the network, the flow network. Okay, so the water going to flow. Okay, water going to be connected. So this is what water flow. Okay, so here we are setting the sensors. So we have the sensors. So for example, here 10 liters of water is coming in. So definitely at the end, it will be what? Same 10 liters. Otherwise, maybe small amount of water will be reduced due to somewhat some leak, something, from erosion. Otherwise, some friction problems. Maybe some amount of water we can expect in less, but it should not be what more. So if 10 liter means approximately equal to what 10 liter should be in other end. So if you are not get 10 liter, then there will be a what back pressure. There is a what back pressure act on in between the what the pipeline. Okay, so so the flow of the water will be affected. That's why in one house they're getting more water. Maybe in other location they are not getting water, because there is a what back pressure in the what system. Okay, so the main reason for the back pressure is what? Internal erosion, corrosion, and what? Scaling. That means what? The deposit of salt. Okay, so here we have to identify the critical zones. We have to identify the critical zones. Critical zones means where what that water flow is less, or where that internal erosion, otherwise corrosion, otherwise the salt deposit takes place inside in between the what pipelines. And then pressure and flow distribution analysis. So we have to analyze the what pressure and flow distribution. Okay, so here the mathematical modeling is what very important to identify the critical zone, and as well as to what analyze the what distribution of the flow and what pressure. Then estimation of flow parameters. Here the parameters may be velocity and density. Okay, for safe distribution. Okay, so here flow distribution, not to violate the law of what? Conservation of mass and energy. So there is a what there is a law for what? Mass and energy. The flow distribution should not affect it. Then flow properties predicts the what? Distribution. So here the mathematical model involves partial differential equation, Laplace transform. Here we can use differential equation also. So by using our mathematical tools, otherwise we can use our mathematical idea, we can find the what? This is Bernoulli's equation. So Bernoulli's equation. Okay, so we can find out the what, otherwise we can figure out the what? The flow management system. So where the problem occurs in the flow management system. Okay, so these are the what? One of the very important mathematical model using in automatic flow management system. Next, I want to discuss with you automatic leakage monitoring system. Okay, so the first one, monitoring, so that the flow monitoring system. If flow monitoring system is not is affected, then there will be a what? Leakage. For example, this is the network. Okay, we have the pipe, we have the what? Pipe. I can say this is what, Q1. Okay, this is what, Q2. So the Q1 and Q2, the pressure at Q1 and pressure at Q2 supposed to be same. Okay, if there is what about what we can write here? Q1 equal to Q2 plus all loss. That will be a loss. Just now we discussed. There will be all loss. So if Q1 equal to Q2 plus loss, then okay, no problem. But if it is not equal, then there will be a what? A leakage in the what? In the pipeline. So this will be figured out by using what? Proper mathematical model. See that here, this is, depends on the length of the what? Pipe. If the length increases, okay, the friction loss, FL, friction loss will what? Increase. If the length of the pipe increase, friction loss also increase. So how we can identify the location of the what? Leakage in the pipe? Okay, so we have to take, it is what? Iteration. First we have to take L at 0. Okay, then we have to take L equal to 5 meter or 5 centimeter, something like that. So L equal to 5. If it is converged at the point Q1, then there is no problem. If it is converged at the point Q2, no problem. If it is not converged between 2 points, then we can identify that there is a leakage in the what? A system, otherwise in the pipe. So that point will be monitored. It will be identified. So then we need what? Flow modeling. Okay, it will be identified by using flow modeling. Measurement of flow parameters based on what? Length L. Flow loss measurement to distance L. Flow loss measurement to distance L. So in this model, you going to use, okay, what is the distribution here? What is the mathematical application here? So we are going to use continuity equation to modeling the system. Okay, so after that, if you're going to analyze the system, we can find that where that exactly that leakage takes place. So this is what one of the very important mathematical model using in the what? Water management system to identify the what? Leakage of the pipe. Next, I want to discuss with you design of wind turbine. Okay, design of wind turbine. So you know that the wind what? Wind system. Okay, so this is what? The wind, right? Okay, so before that, in our few years before, the wind turbine pole, this length is less, and then the size, otherwise the length of the what? Turbine blade also less. So it cover what? Less area. Otherwise the diameter will be what? Will be less. The diameter, right? This will be less. It will cover what? Less area. Okay, so if more wind, it will rotate fast, and it will collapse. Even though if it rotate fast, the generator speed will be same. So now if you're going to see, there will be what? The pole height, it is what? Increased. The pole height is increased, and the length of the turbine blade also increase. So this is by designing of wind turbine blades. So aerofoil theory, which includes a thrust, a lift, a weight, and drag. For an effective system, the lift should be increased and the drag should be what? Decrease. So this is the word very important in any model. So the lift force, this should be increased, and the drag force, it should be what? A decrease. Okay, so here we are modeling by using mathematical applications. Okay, so here we can see here a lift. You can see the lift force generated by aerofoil optimal. Then there will be a what? Thrust and drag. So this two considers a what? Parameters here corresponding to lift. Then optimize energy utilization. So we have to optimize the energy utilization by using everything what calculated, otherwise solved by using what proper mathematical model. So here we use integral equations. Here it is compressible flow. Last two is a water, right? Incompressible flow. But here water, that is air, right? So it's called compressible flow. So here we can use what? We cannot use actually the Bernoulli's equation. So here we are going to use what? Pascal law to find the what? Design, otherwise to design the what? Turbine blades. So this is what one of the what major application of the mathematical tool in designing wind turbine blades. Next one, waste management system. Of course, just now I discussed with you, these three are very, very important. Okay, one is what? Water management system, power management system. So for the smart city, the power will be generated there itself. Okay, so next one, waste management system. So here it is what very important, because many area, even in India, many places, there is no systematic regulation in storing what? The waste. There is no systematic regulation for storage, for collection, transportation, and processing, and what? Landfilling. So it affects the what? Public health principles, economy of the particular region, otherwise the country, and so on. So we need a what? A proper, otherwise comprehensive, practical solution. So we need a practical solution by using proper mathematical modeling. So here we can use what? Dynamic programming model, that is called by targeted model. So by targeted model means it is targeting economy, productivity, as well as environmental pollution. Okay, so by using proper dynamic programming model, we can find proper waste management system. Okay, so there in many areas there is no solid waste management system. There is no proper solid waste management system. So by using our mathematical model, we can describe, otherwise we can make a waste management system model to give our recommendation to what? Our municipality, otherwise the people who are in charge. See here we have two things. One is biological material, that is decomposed waste, and non-decomposed waste, that is called technical material. So there will be a collection. So here what they will do is they will use they will give it to the users. Okay, they will reuse it. Then they can go and what? They will make a what? Reproduce also. They will make reproduce. Okay, they will collect and they will reproduce, and they will make a what? Another product. Okay, so here in the biological material that will be collected, it will be used, is user friendly. Some ways to go and be user friendly, it will be used. I use it again. Otherwise, if it is not use it again, they will make it into biogas by adding what? Chemical substances. Okay, they will make into gas. Okay, so the deposited the extra, otherwise deposited waste, it will be used for soil. Used for what? Soil, otherwise we can call is a what? Fertilizer. So in this way we can regenerate, otherwise we can reuse, otherwise we can reduce the what? Waste. So if a country having effective solid waste management system, 80% of the waste going to be what? Recycled. Only 20% of the waste will be what? Waste. Otherwise they will make it into what? Fertilizer or whatever it is. So that most probably all the waste, it will be what? Reuse it again. For example, we can consider China. Okay, the products are very less. The cost of the products are very less. They're giving chapel for one pair of chapel for 30 rupees, whereas Indian product Bata, it is costing 300 rupees. See the difference? Because this waste management system in China, it is very effective, because they're reusing the what? Waste, and they're making what? Another product. So that's why what the waste management system should be what? Very, very important to maintain our what? Environmental clean and healthy. I can discuss with you more mathematical models. Actually, okay, fine. See, these are very limited. Okay, I can provide you more mathematical models where where our engineering skills or engineering mathematics are very helpful. Okay, here I want to discuss you very important point before going to conclude my my presentation today. The very important thing is there is a gap. Okay, so even though we are giving all the basic mathematical skills to our students, but there is a gap between the concept, otherwise the basic concept, and the application. That's why the student is asking where I'm going to use this mathematics idea in my real life or in my engineering discipline. Okay, so to fulfill this gap, the university and colleges, they're making what, otherwise they're revising the curriculum in regular intervals. Okay, in many of the universities, their teaching is based on learning outcomes. It is not what based on what topic, otherwise based on chapters. There will be a chapters, of course, but it will be supported by learning outcomes. There will be a learning outcomes. For to support the learning outcomes, they will collect the what is that chapters, otherwise topics, but they will create their own course material to support the each and every learning outcome. Just I want to discuss with you for next few minutes about the learning outcomes, learning outcome based approach in teaching. See that the learning outcome, realize the importance of ordinary differential equations and their practical applications. Okay, that is the learning outcome. So the learning outcome is developed, the course teacher, otherwise the department, they have to make a supportive material to fulfill the requirement of the learning outcome. See that this learning outcome, it is talking about the ordinary differential equation. When I can realize the importance of ordinary differential equation, after once you are going to be give the application, so the proper application will be there. The next one, formulate a differential model relationship between variables in physical phenomena. So that's why the student mathematical models are the student, they are not aware about the mathematical models. So in the curriculum itself, if the student, they're going to make a mathematical model, small simple mathematical model in their curriculum, it will be very helpful for the students for their future studies. Investigate the stability of solution of differential equation. Investigate the stability of solution, okay, by using our boundary conditions. Sketch the solution of differential equation in the phase plane. We are solving the differential equation. We're giving the idea how to solve the differential equation by using various techniques. How, apart from that, how we can sketch the differential equation in the phase plane. Next one, use of governing differential equation to predict the behavior of the system under various boundary conditions. See the next one, realize the governing differential equation frequently arise in engineering situation. See that learning outcome, it will be framed by the university. Then that the department, they're supposed to prepare their own material. They have to collect the material to support the learning outcome, to cover the learning outcome. So this learning outcome approach is very famous in many of the universities. Now this is the development in the curriculum development side. So the curriculum development, it should be take place in periodic intervals, in regular intervals, to fulfill the expectation of the technology developments. See that another learning outcome, deal with partial differential equation and their application in engineering context, demonstrate knowledge of role of statistics in engineering, not only the statistics, not only find statistical measures, apart from that, distinguish the knowledge of the role of statistics in engineering application. That is the important thing in the learning outcome. Apply reliability concept for lifetime expectation of engineering products, and then utilize statistical analysis software. So we have plenty of statistical tool and software, but the student, they are not using it in their curriculum. It should also include in their regular curriculum, so that the students they are able to understand the concept. Apart from that, after understanding the concept, they can realize the what importance of mathematics and how they can make a model, engineering model, by using mathematical tools. Okay, so this is the word very important. It's a big topic. We can discuss learning outcomes, the development of learning outcomes as a word one presentation, because this is what very important. So far we discussed the what importance of mathematics, otherwise recent advancement of engineering mathematics. All this advancement support by a proper development in the what curriculum side. So in parallelly, so if the technology increasing or developing, or it is developing every day, the curriculum also what revise periodically. So by revising the curriculum periodically, we can meet the what expectation of the what technology developments. Okay, so these are the reference for my today's presentation. Okay, so from my side, thank you so much for the listening. Thanks for the opportunity to discuss with you the recent development of engineering mathematics. Thank you so much.
Participants can raise their queries now.
Good evening, sir. I am Dr. H. Krishnan, Head of the Physics Department, SRM Valliammai Engineering College.
Yes, sir. Very good evening, sir. How are you, sir?
Fine, sir. Very nice presentation. And it is the order of the day, because as we know, that is engineering mathematics is one of the main subject, especially for engineering graduates. Even in the postgraduate engineering course also, students are studying mathematics because that much importance was given, and it's well taken. And especially when you are talking about this curriculum, that is periodically we have to change, and we have to inform the students how mathematics is interlinked with all the interdisciplinary courses in engineering. So I think it's a very nice presentation, and our faculty members and HOD madam will take care when they review for the syllabus, because ours is the autonomous institute. So we are having that freedom to set the syllabus.
We have the liberty.
So
that's why.
Yeah, that way, even when you are talking about this data science, it is a very new subject. People are talking in the computer science after clouding, data mining and all. But now this data science is mathematics is one of the main thing. Even in the machine language, all computer oriented things, mathematics is very important one. And as you said, for all physical, even it's a mechanical problem, or even in the civil problem, the waste water management or something, what they're talking about it. And really it was very interesting and very useful to our students as well as our faculty. And it's an eye opener, this one. In fact, when I saw the topic, because when we always used to say a thing, then a lot of integrals will be there, a lot of differential equation will be there, but a lot of theoretical and understanding PPT was well prepared. In fact, was really, I appreciate you, sir. Very nice presentation. Thank you very much for your guidance. Definitely, we will take care note of your points, and we will do review our syllabus and then and there, so that our students will get a maximum benefit. As a faculty, we have to give a lot of clarity. That is, when we studied engineering mathematics, we know M.K. Venkatraman, that is a Karakudi person, that book, and Kandasamy, that is engineering mathematics from PSG Tech, and all will be there at that time. And then afterwards, now many people have come, and even engineering mathematics by Graysick, that also people used to follow. And mathematical physics also, as you are aware, very important subject, very this one. So I really very much appreciate your presentation, and thank you very much, sir. So this is from my side. Thank you. Thank you.
Very kind of you, Dr. Krishnan sir. Thank you so much. Really, I'm very happy about your feedback. It is my pleasure also, because earlier I was there in India, in Tamil Nadu. I was there in engineering college. I know how I taught there. So what are the curriculum? What we discussed as a problem? See that there also their questions are more. Why the student, they normally they used to ask, what is this? What is the integration? Where I'm going to apply this derivative? Everything there. Definitely I don't have any answer, because my curriculum not allow me to what beyond our what is that solving of problems. But if after coming here, after seeing the approach of the learning outcome approach, so that the course material, everything supposed to be designed by the teacher, because I shown you the learning outcomes, right? So there is no course material, there is no book available for fulfill the expectation of the learning outcome. So the course teacher, they supposed to, that means what the course teacher supposed to develop their own material by collecting the resources to fulfill the what requirement of the learning outcome. So finally it will be a it's going to be a full cycle. The cycle is going to be, it's going to be there with the application. So the student is able to know that the applications. So that's why it's taking place. It is very helpful for the teachers and students for their projects, for their research. So this is amazing. That's why I want to conclude with the word development of the learning outcome. Thank you so much, Krishnan sir. Thank you so much.
Good evening, sir.
Thank you so much, sir. Sir, excuse me, sir. I'm Dr. Chitra. Thank you, sir. Dr. Krishnan, sir. Your feedback was very nice. And then I'll follow the informations for what he has given. We'll change the curriculum now, sir. We are discussing about it. I'll replace that in following the curriculum, sir. Sir, I just wanted to share that sir, physics HOD sir is our chairman of Science and Humanities. So I'll discuss with him and then we'll change it, sir. And I just wanted to share a few things that it is a very nice, wonderful presentation. Definitely, what you said, we will take it in account and then we'll follow that, sir. Nice presentation. You are taken into a different platform. Thank you so much, sir. We are blessed to have you in our today's webinar, sir. Thank you so much, sir.
Thank you, Dr. Chitra ma'am. Thank you so much. Sorry for that the inconvenient caused by being while sharing the screen. I don't know what happened. I will check the things later, because you mentioned that some of the screen not shared. If it is required, I will share my screen later. That means what?
No problem. That's okay. Yes. No problem, sir. Technically, there may be there are some problems. No problem, sir. Not a problem. Fine.
Thank you.
Thank you so much, sir. Sir, this is Vijay Lakshmi. Thank you so much, sir.
Good evening, ma'am. Good evening. Thank you for the invitation, because I got.
Thank you, sir.
Thank you for this nice opportunity. Thank you.
Thank you.
If any question from the audience.
Yeah, busy schedule, you accepted our invitation. Thank you so much, sir.
Thank you. Thank you. It's my pleasure.
Good evening, sir.
Yes, ma'am. Good evening, ma'am.
Sir, I am Professor Tamil Selvi, working as an assistant professor at MGM's College of Engineering and Technology, Navi Mumbai.
Yes,
sir, I have a doubt. You are in your PPT, we have seen in image denoising, DCT transforms we were using. So my question is whether the discrete transforms will be better or the continuous transform will be better for image denoising.
It depends, ma'am. It depends. Most probably the continuous image processing, it will be better.
Okay. Okay, sir. Thank you. And other thing I want to mention is, since we have all the branches almost which you have told, and really I have learned a lot. That really in the application side, so many things we have learned. It is really a knowledge gaining session, sir. Thanks a lot for your. Sir, one more request. Can you please share your PPT to us?
Sure, ma'am.
It was a wonderful presentation, sir. Not many things we could learn, even though we were there in this field so many years. Thank you, sir.
Even for me,
ma'am, I just wanted to say a few things, ma'am. What are all the events we are conducting in our SRM Valliammai, we are going to post that in YouTube, ma'am. The YouTube link will be shared with you. You can see anytime in the YouTube.
Okay.
This full program will be uploaded in YouTube, ma'am. This is the protocol we are using. So if you see SRM Valliammai YouTube the channels, you will get all the programs will be uploaded, madam.
Okay, thank you,
Commercial
ma'am.
Valliammai, madam, this is for your information.
Yeah.
Anybody wanted to see, you can see that in the YouTube link.
Yes, ma'am. That's a good idea. Thank you, ma'am. And other thing,
Sir,
one more thing I want to tell, sir. The gap you were telling, na, the learners outcome. Even in Mumbai University, syllabus revision, we have made that, sir. We have tried to accommodate the gap filling. Now the students are having more interest towards engineering maths. That's what we were seeing in this time syllabus revision. We have taken into account this one, and we have given according to the learning outcomes.
Of course, ma'am. Of course, if there is no development of the curriculum periodically, definitely the teachers will get boring, and moreover the students also getting boring, and moreover there is no connection between what the reality and the application. So maybe that university, otherwise the college authority, they have to take care of revising of the syllabus in periodic interval based on the requirement of the technology development.
Yes, sir. Yes, sir. It's 100% true, because we were seeing the real difference in that, sir.
Thank you.
Thank you, sir.
Welcome.
Yeah, sir. Good evening, sir. Hello, am I audible?
Yes, sir.
Hello.
Hi, sir. Go ahead, sir.
Yeah. So I'm myself, Dr. Uday Kashyap from Mumbai.
Yes, sir.
Yes. So first, let me appreciate to you. The presentation is very fantastic, and you have covered entire the session, and that I hope that it will helpful for all mathematicians. Of course, I feel that, sir, mathematics, if you not use in engineering what you are today's with respect to today's session, so that will remain only philosophy if you not use in engineering. The mathematics only then philosophy, and of course in engineering without math is simply called I think that nothing. So, sir, very nicely, but in between one PPT, I have one doubt. That like the COVID model you have explained very nicely there. So my one doubt is, sir, that N of T, that number of the people you have selected for susceptible, or you can say infected, that things. So are they constant, or some that it is going to that added in this case variable form? So that is my one question.
Yes, sir.
With respect, I mean that there are the two chances. That like the pack of card we are doing. That pack of card we are keeping aside one that the card, and we are doing one experiment, or we can again adding and that again we are doing experiment. The same thing is there. Are the number of people are going to increase in that n, or whatever sample space you have taken, that is a fix, and then you are doing that. Then you have developed that model. So that is my one question. And second one that related with that question, if it is suppose constant, then what I feel that what I was thinking on that model, if you take a rate of change of that susceptible with respect to time, then plus rate of infected with respect to time, you have written that n of t is equal to s plus I, something like that way, then that will become is equal to 0 then, sir, if it is constant.
It is not a constant. Right? Yeah, it is not a constant. It is not a constant. Okay, so the effective rate every time it is increasing. It is not a constant. Okay, so if you're going to take a constant, that we cannot make a conclusion. We cannot make a proper conclusion, because constant means everything finished. We cannot there is no development, there is no change in future. So the infection of the virus, it will be what keep on changing, whether it is going to be increasing in nature or it will be decreasing in nature. So we cannot keep it as a constant.
Okay. So correct. But suppose we think that we have taken one sample group of the fixed people, and then fixed people I'm talking, we want to implement that model on fixed, the number of people. If assume that there is no addition of any single person inside in that, and n is equal to 0, then definitely that if you differentiate that each, the suspected, or you can say that, then it will become is equal to 0. And I think that then some that will become more, the precise model what I was thinking right now. But anyway, we will work on that. I will think on that. You have given very good thought to me to work on that. So thank you, sir, for your very enlightening sessions and informative sessions for us. Yeah.
Thank you so much, sir. Thank you so much.
Yeah.
Sir, just wanted to share one thing, sir.
Yes,
I'm Chitra. Sir, actually, I'm happy to share with you that we, the maths department staff of SRM Valliammai, we have just made one book. We worked all together and we have just created one book. It is consisting of all the applications of mathematics and engineering subjects. We took some 1 year time, and I have to thank our principal, sir. He only motivated us to do that. So we all together, we have just published one book. In that book, all the engineering topics will be covered, and what all the mathematics we are using in engineering, all the applications have been mentioned in that, sir. One first version of the book has been already published and it has been distributed to our students. The students are using it. The second version is already ready, sir. I have to thank, in this juncture, I have to thank our principal, sir, Dr. Rajan. He only motivated. And I don't want to, if I am not mentioning our vice principal, Dr. Murugan, sir, it is not fulfilled. He also supported us to do it. I'm proud to mention this situation, sir.
Yes, ma'am.
Thanks,
I'm
our
very
staff.
happy to hear this thing, the development. Thank you.
Yes, sir. Yes, sir.
Thank you, sir, for patiently clearing doubts. And thank you so much for your amazing lecture. We learned a lot about the recent advances in engineering mathematics and how maths played a vital role in finding the transmission pattern of COVID-19. We feel proud and privileged to have you here with us. Thank you so much, sir.
You are most welcome, ma'am.
Gratitude is not only the greatest of virtues, but the parent of all others. I now invite Vasaki ma'am, Assistant Professor, Department of Maths, to render the oath of thanks.
Good evening to all. On behalf of our department, I take this opportunity to propose vote of thanks on this special occasion. First, I must thank our chief guest, Professor Dr. R. Pugularasu, Head of Maths Section, University of Technology and Applied Sciences, Ibri Sultanate of Women, for accepting our invitation and also for his wonderful lecture about recent advancements in engineering mathematics with many real-time applications. The lecture gave deep insight into the topic and was really informative. Thank you, sir. I express my sincere gratitude to the management for providing the opportunity to organize this webinar. We offer our sincere thanks to our principal, sir, vice principal, sir, for permitting us to conduct this webinar in a grand manner. I would like to thank our head of the department, Madam Dr. S. Chitra, for her encouragement and moral support for organizing this webinar. I extend my gratitude to Professor Dr. H. Krishnan, sir, head of the department, Department of Physics, and Dr. K. Tirupati, sir, Department of Physics, to take part in this webinar. I especially thank the program coordinators, Madam Dr. T. Isayarasi and Madam Dr. V. Vijayalakshmi, for their continuous effort to make this webinar a successful one. I thank our department faculty members for their kind support in organizing this webinar. I thank our student, Ms. B. Muthukriba of second year computer science, for her perfect comparing throughout this program. Next, I must thank all the participants, students and faculty members of various institutions for their active participation and also for their patience listening and learning. With your presence only, this webinar is becoming a successful program. So once again, I thank you all.
Thank you, ma'am, for your words of gratitude. We have now come to the end of the event. Participants are requested to fill the feedback form posted in the WhatsApp group, and the link is also posted in this meeting's chat box. All the participants will receive the e-certificate. Thank you all.
Okay, thank you, madam. Thank you, sir. Thank you. Thank you.
It's working.